Welcome to The Explainer. Today, we are going to pull back the curtain on something pretty amazing. Those complex, interactive UI designers. You know, the ones that somehow magically run entirely inside your web browser.
I mean, it really does feel like magic, right? You're watching elements snap into place, resize, and layer perfectly, all on a web page. But, spoiler alert, it's not magic. It's actually a really clever separation of data, user interaction, and what you actually see on screen. And that's exactly the pattern we're going to break down today. So, to really get our heads around this, let's think about it like we're building a house. First, you've got the engine. That's the architectural blueprint, the master plan. Then you have the designer, which is basically the construction site where you see it all come together. And finally, there's the tree, which is kind of like the project's table of contents, keeping everything neat and organized. All right, so here's our game plan for this explainer. We're going to start with the anatomy of the UI designer, then dig into the engine, the data and logic. From there, we'll look at the workspace and the tree, which are all about visualizing that data. Then the fun part. We'll follow an action from start to finish. And finally, we'll wrap up with the big picture, the architectural takeaway. Okay, let's get right into it, starting with the foundation. The engine. This is all about the data and logic, the application's source of truth. You can really think of this Sithaso layout engine as the brain of the whole operation. Now, here's the absolute key thing to understand about the engine. It is completely, 100% disconnected from the user interface. It has no idea what pixels are, it doesn't care about clicks or drags. All it does is manage the raw data that defines our layout. It's the pure, unadulterated blueprint. That's it. So what happens when you go to load a design? Well, a lot of the time, it starts out as some compressed binary file. That's where this BJL converter thing jumps in. It's its job to read that file, decompress it using Paco.js in this case, and then parse all that data into a structure the engine can actually understand. Once that's done, the engine is ready to roll. And this right here is a perfect example of the engine's power. It gives us this really clean, high-level way to talk to our layout data. You see this method add component? We can just call that to add, say, a new button. The engine takes care of all the nitty-gritty data changes under the hood. We don't have to worry at all about how it's going to get drawn on the screen later. Okay, so we've got our blueprint, the engine. Now we need the place where we actually build the thing, right? Let's move on to the workspace. This is the main view, and this is where we visualize all that data. So this component, the Sithaso BJL-Designer, is pretty much responsible for everything you see and do on the canvas. We're talking rendering the shapes, handling all the drag and drop stuff, keyboard shortcuts, mouse clicks, the whole shebang. It's really the main bridge between you, the user, and the data sitting in the engine. Now check this out, because this is where things get really interesting. See how the designer also acts as the controller? It's just sitting there, listening for keyboard events, so when you, say, hit Ctrl-Z to undo, this code kicks in. But notice what it does. It doesn't start messing with pixels directly. No, it just calls its own undo method. It's translating your physical action into a command the application understands. So yeah, the designer is a real workhorse. It's juggling a ton of different jobs. It has to read the data from the engine to draw everything. It's in charge of complex stuff like the undo/redo history and the clipboard. And maybe most importantly, it has to shout out any updates to the rest of the application, so all the different parts stay perfectly in sync. But the workspace, that main visual canvas, isn't the only way we can look at our design. There's also the tree, which gives us a totally different perspective. It's a second view, a synchronized hierarchical outline. Basically a table of contents for our entire project. And what this does is give you, the user, another way to see and interact with the exact same data. It's all connected. You can click on an item in this tree list and boom, it gets selected on the main canvas. And it works the other way too. It's just another window into that same source of truth in the engine. So you might be wondering, how do these two different views stay perfectly in sync? Well, here's the secret sauce. They are loosely coupled. The tree doesn't boss the designer around, nope. Instead, when you click something in the tree, it just sends up a flare. It fires off a custom event, like delete node. The designer, which is listening for those flares, sees it and knows exactly what to do. It's such an elegant way to keep them working together without being directly tied to each other. Makes everything so much easier to manage. All right, theory is great, but let's see how all these pieces actually dance together. We're going to trace a single, simple command, duplicate, from the moment you press the key all the way to the end result. Let's follow the action. Okay, step 1. Our story begins with a single key press. You, the user, press Ctrl-Shift-D, and instantly, that event listener we saw earlier, the one living inside the designer, wakes up and springs into action. And you might expect some super complicated code here, but check this out. The duplicate function is actually incredibly simple. It's smart, not complicated. It doesn't reinvent the wheel. It just says, hey, I'll just call the copy function, and then right after that, I'll call the paste function. That's it. Okay, so the paste method, this is where the heavy lifting happens. First, it makes a perfect copy of the item that's on the clipboard. Then it gives that new item a brand new, unique name so there are no mix-ups. And then, and this is the most important part, it adds that new item directly to the engine's data. Just like that, the blueprint itself has been changed.
But of course, changing the blueprint isn't enough, right? Nobody can see the change yet. So right after it messes with the engine's data, the paste method makes 2 more calls, update workspace and _update outline. It's basically tapping both the main designer and the tree view on the shoulder and saying, hey, something changed, time to redraw yourselves. And that's it. The whole action is complete. The engine's data is updated, and that change immediately triggers a synchronized UI refresh. You see the new item pop up in both the main workspace and the tree view, all at the same time. The flow is just so clean. User input to data change to visual update.
So, let's zoom out for a second. We've seen the nuts and bolts, but what's the big architectural takeaway here? What's the powerful idea behind all of this? It really comes down to the power of separating concerns. What we've been looking at this whole time is a classic, beautiful software design pattern called Model View Controller, or MVC. Our engine, that's the model. It's the one and only source of truth for our data. The designer and the tree, those are our views. They're just different ways of looking at the model's data. And the controller, that's the part in the designer that listens for your clicks and key presses and tells the model what to change. Model, view, controller. So why does this matter so much? Why go to all this trouble? Well, this separation of concerns is just incredibly powerful. First, it isolates your data logic from your UI, which makes your app way more stable and easier to debug. It also makes it super flexible. Imagine you want to add a new properties panel on the side. Easy. You just build a new view, tell it to watch the model, and that's it. It'll automatically stay in sync with everything else. It's brilliant.
So now that you've seen this pattern in action, this blueprint for separating what your data is from how it looks, you have the key to building your own complex, interactive web applications. So the only question left is, what could you build with it?